Hello and welcome. In this segment, I'm going to discuss about radicals and how to identify a rational number or irrational number being in the radical form. Also, if that radical is a real number or non-real number. So let's start with defining what a rational number is. A rational number is any number that can be put in the form a over b. Notice it has to look like a fraction, or you could put it in the fraction form where the numbers a and b are integers, and the bottom, of course, the denominator cannot be 0. So any number you can write in the fraction form is a rational number. So sometimes you're given the number in the fraction form, like 2 over 5. 2 is an integer, 5 is an integer. So you're dividing an integer by an integer where the bottom integer is not a 0. So I classify this to be rational. Okay, now 75 hundredths, it's a terminating decimal. So I don't have any digits beyond that. And if I do, they're zeros. And so I can read the 0.75 as 75 hundredths. And if I read it as 75 hundredths, then I can write it as 75 hundredths as a fraction. And so if you have a terminating decimal, it's always easy to put it in the fraction form. So I call this also rational as well. If I have a repeating decimal, like 0.3 repeating, then that repeating decimal, there is always a way to write it as a fraction. Notice that 0.3 repeating is 0.3333, and you may remember that 0.3333 is equal to 1/3. In fact, we could take that repeating digit, if it's one digit, which is a 3, if you divide it by 9, you get 1/3, and that's how you change it from the repeating decimal form to a fraction. So any repeating decimal can be put in the fraction form. For example, if you have 0.27, both digits repeat, then this can be written as a fraction by taking the repeating digits and dividing them by 9. And that can reduce to, if you divide by, say you can divide by 9, it's a 3. You can divide by 9, it's 11. So if you go to your calculator and divide 3 by 11, you're going to get 0.27, 27, 27, 27, and so on. So that would be also rational. So a repeating or terminating decimal are rationals. And of course, if you have a whole number, is rational. For example, the number 5, you can write it as 5 over 1, so that makes it rational as well. Okay, so, but if we look at numbers like the square root of 2, if you punch in, try to evaluate the square root of 2 in your calculator, you're going to get 1.41421356, and it goes on and on and on, but it does not repeat and it does not terminate. So it's not the same case as a repeating decimal like 0.75. It's not a case like a repeating, a terminating decimal, I said here, and repeating decimal right there. So those digits do not terminate and do not repeat. And so that's why there's no way we know what the next digit is going to come up, so we can put it in the fraction form. So something like this is called irrational, because we don't know what the next digits are going to be, and it goes on to infinity, so you can never write it as a fraction. Same with this one, 5 times the square root of 3. Well, since 3 is not a perfect square, we cannot simplify it, and so the answer would be, if you find the square root of 3 and multiply it by 5, you get 8.6602544035, and it goes on and on, does not repeat, does not terminate. So that as well is rational, is irrational. Irrational. You need to catch my mistakes. Okay. Now, let's go here to this example, cube root of 27. Well, the cube root of 27, since 27 is a perfect cube, then that answer would be a 3, because 3 cubed is 27. So 3, we can write it as a fraction. We can put it 3 over 1. So this is rational. While the cube root of 26, 26 is not a perfect cube. And when you evaluate cube root of 26, it's going to give you digits that do not repeat, do not terminate. So this is irrational. So you probably got the point by now. If you have a perfect square under square root, it's going to give you a terminating decimal, which can be put in the fraction form. But when you have a number that cannot be simplified under the radical, then it's going to be irrational. OK, so we go back here also, the fifth root of 31. Well, the fifth root of 31, 31 is not a perfect power of 5, 32 is. And so this is not going to simplify to a terminating decimal. So that's going to be also irrational. Keeps going on and on. It does not terminate, and it does not repeat. So that's the difference between rational and irrational. If we look at the number pi, popular number pi, which is about 3.14, and that goes on and on and on. So if you punch pi on your calculator, it's going to give you an irrational number. Digits don't repeat and do not terminate, and that's why pi is an irrational number. OK, so let's move into the concept of real and non-real. If you have a negative number under the square root, think, if I want to simplify it, I'm looking for a number that when I square, I get negative 25. So can you find a number, you square it to get negative 25? The answer, I'm sure you said no, because every number you square is going to be positive, and there's no way you get a negative number there. So that's why we say this is not a real number. OK, so if it's not a real number, you cannot locate it on the real number line. And it's beyond that. And I'm sure later when we discuss imaginary complex numbers, you're going to understand this better. Cube root of negative 8. Can you find a number you raise to the power 3 to get negative 8? And the answer is yes. If you take negative 2, raise it to the power 3, that's going to give you negative 8. So the cube root of negative 8 is real, because that's equal to a negative 2. So the answer to this is negative 2. And that's a real number. We can find it on the real number line. If you have a fourth root of negative 16, ask yourself, can I find a number and raise it to the power 4 to get negative 16? And again, that's the same issue there. When you raise a number to an even power, if it's negative or positive, it's going to give you positive. So there's no way you find that number. So that is non-real. And then the fifth root of negative 32, again, ask yourself, can we find a number, raise it to the power 5 to get negative 32? And the answer is yes, because if you take negative 2, multiply it by itself 5 times, it's going to give you negative 32. So this is real. So you notice that if the index is even and you have a negative number under, that's not real. So even index negative is not real. Even index negative is not real, while odd index and negative is real. Odd index and negative is a real number. So hopefully you can differentiate between rational, irrational, real, and non-real. See you next time.